questions, I'd be happy to follow up. But we're all seeing the world now through, what we call unmanned aerial vehicles or drones. And these things come in a variety of shapes, forms, uses all the way from commercial to military. I'm working with a company actually called Aeronide. They do inspections of power lines with drones. So they fly over power lines or power plants or substations and do inspections with these. So there's all kinds of purposes. Essentially though, what's happening is we're evolving into what are called swarms. And what swarms are a collection of unmanned aerial vehicles, and they communicate and coordinate with each other to achieve a set of goals. So they must communicate and do it in a way that's secure. So one of the big questions is, what happens if a malicious drone entered into this network and pretended to be a friend when it's really a foe? Perhaps it's going to thwart a mission or do some damage of some sort. And this is one of the practical problems that we've been interested in fixing or resolving or addressing. So the way these work is what we refer to as agents. And agents are kind of a broad term that are used to apply for different things. We can think of an agent as anything that can perceive through a sensor its environment. Whoops, go back, sorry. Through its environment, and can act upon its environment through what are called effectors. And its it's eventually trying to achieve a goal, but it can do this, or it typically does do this, through a cooperative social organization. In other words, agents communicate with each other. But these agents have different degrees of sophistication, different size computers, different software, different capabilities that they have. So some take on more of a duty than others. In the past, it's been that these agents have worked with some sort of a controller. If you're talking about unmanned aerial devices, there's typically been a ground controller, but as these become more autonomous, they actually use each other instead of a ground-based system. I'm sorry, I forgot to take the animation off. So, but basically what a goal-directed agent does is it acts upon its environment, and acting can simply be a matter of communicating with other agents, in this case, other drones in the sky. And then basically the way it works is through the sensors, it perceives its environment, and it has a certain amount of intelligent capability built into it. It understands its current state. It might be the altitude, the speed at which it's traveling, the vectors that it's taking, other items in the sky besides other drones, birds and so forth, trees, other obstacles. It understands what its goal is, and then what actions it needs to take in order to accomplish its goal. And it does it through these, what are called effectors. In this case, it might be moving the flaps of the drone, or it might be changing the altitude, or taking some evasive action. So these work in what are called mobile ad hoc networks. And the concept here that we've employed is something based on what we call danger theory or damage theory. In essence, what it does is when a device joins a mobile ad hoc network, and these devices can come and go at any time. They take on different roles as they join a network and leave. What we're interested in making sure is that we have a way of determining whether this new device that's joined the network is friend or foe. So initially, there are drones that would be set up for monitoring the activities of other drones. And for example, if a drone tries to send malicious traffic or tries to do something that's outside of its goal or set of actions toward its goal, then it can be neutralized in a variety of different ways. So we determine this state as what we call danger. It's highly monitored, and as long as the device obeys the rules, then it becomes monitored less and less over time as it becomes trusted. And it uses a sort of, you might think of it as a reputation-based system where one agent or one drone will ask others in the network, have you worked with this new agent that's joined the network, and if you have, was your experience good or bad? In a sense, it's all done in software. But as long as it's good, its reputation value improves. And as it does improve, it becomes more trusted and is monitored less. And then only if it causes some sort of damage, then it will either be monitored depending on the kind of damage that it does, be monitored again, or it'll be essentially blocked from the network or any communication or interacting with the network. A lot of people relate this to agents that are working with autonomous land vehicles. For example, autonomous vehicles have a variety of agents that have different functions. So you might have an agent that's responsible for keeping the automobile in its lane, but you'll have a collision avoidance agent that has sensors that can detect things like a ball rolling in the street or another automobile. And the collision avoidance agent will override the keeping in lane agent and enable the vehicle to take some evasive action. In the case, and this is a highly technical diagram, and I apologize, it's for software folks if you're not that. Let me just explain what this does. So in this process, it works a little, we use what's called the biological inspired approach in these agents. In a sense, an agent can be a person or a device. And agents have a configuration, in this case, a software configuration, the operating system, the files it uses. All of these things can be known and protected and have integrity checks on them. A particular agent will have roles, it can perform certain actions based on what its permissions are, and all of these things become what is known as the self. So the agent knows itself by these types of configurations and permissions and profiles. Agents identify other agents as self versus non-self, and they're benign non-self agents. The benign non-self agents are those that are participating in the network, that are cooperating and behaving. Malicious non-self agents are those that are trying to cause damage. And so the way the damage is prevented, or at least controlled, is initially a request will be made from one device to another, let's say one drone to another to perform a different action, or one agent within a drone for another agent within the drone. As agents interact, as I mentioned, they check each other's reputations, whether they've behaved and have participated for a long period of time. The requests are determined based on what the agent is able to perform and what it's prohibited from performing. And then the effectors will cause various actions, and then also has certain obligations that it must fulfill. For example, one drone might be a traffic controller drone, and its function is to direct the other drones or multiple other drones on flight path. And I think I'm about out of time, so let me just skip. So agents are becoming increasingly common in networking of all sorts. They're becoming increasingly intelligent. You've heard probably of machine learning and artificial intelligence that are becoming embedded, that are allowing these agents and these autonomous vehicles to become more intelligent as they gain experience. The main issue is there's still many systems incompatibilities. While agents have the ability to make deductions, they're not good at making inference. In other words, if you're an autonomous vehicle and a ball rolls into the street, the agents can detect the ball, but it can't infer that a child might have kicked it, might be running after the ball and might cause the wrong evasive action, i.e. to swerve into the child. So these are still some of the issues that we're trying to solve when we're dealing with drones in general, unmanned aerial vehicles, or all kinds of unmanned vehicles of all sorts. Any questions?
Wonderful presentation, sir. It was very nice to know about the agent between the communication between the drone. Is it because of MANET the communication will be happening?
Is it for me?
Through MANET, the communication will be happening?
Yes, yes. So the MANET, the Mobile Ad Hoc Network is what it stands for,
Yes,
is
yes,
actually a wireless network, just
yes.
like you might have your phone and iPads that communicate.
Mhm.
Yes, so that's exactly how it works.
Okay, okay, sir. Okay, understood. And what would be the any other type of communication rather than MANET, which can also be used and synchronized between the drones?
Yes, excellent question. So because agents are basically just pieces of software and hardware,
Yes.
you might have beyond unmanned aerial vehicles, you might even have satellites. You might have even just mobile devices that are handheld, that are terrestrial. All of those things might participate in the communications over the MANET.
That's wonderful, sir. That's wonderful. I would like to know much more and would like to connect with you.
Thank you so much.
I work with Center of Excellence in Aerospace, so that would be nice to learn more from you. Thank you.
Excellent. I would love to follow up with you. Thank you so
Sure.
much.
Thank you. Thank you. So we'll go ahead with the next presentation.